wondered if the 350 ml Coca-Cola bottle is really 350 ml? Well, you shall learn the answer mathematically. Today, we shall talk about confidence interval and testing hypothesis. I am Dominic Dico, and welcome to the world of statistics.
In our boarding house, comprising of 15 individuals, all the boarders had an average of 8 hours of internet usage. If the standard deviation is equal to 6, create a 95% confidence interval of the mean internet usage of all boarders. On our first problem regarding confidence interval with one mean, here are the given. N is equal to 15, the mean is equal to 8, the population standard deviation is equal to 6, and the alpha is equal to 0.05. In finding the confidence interval, when the population standard deviation is given, we have this formula. Sample mean plus minus z sub alpha over 2 multiplied by the population standard deviation over the square root of n. Next is to substitute. Our sample mean is equal to 8 plus minus z sub 0.05, which is our alpha, over 2, and then multiplied by 6 over the square root of 15. And on the second step, we found out that the square root of 15 is equal to 3.88. Simply substitute. For the z-score, 0.025 has been equated from the 0.05 divided by 2. You look for the equivalent of 0.025 on the table. And then we have found out that 0.025 is equal to 1.96. Substitute again. 8 plus minus 1.96 multiplied by 1.55. That gives us 8 plus minus 3.038, which gives us the confidence interval 4.962 less than mu less than 11.038. Therefore, we are 95% confident that the mean difference of internet usage of all boarders is contained in the interval from 4.962 to 11.038. Confidence interval of two means. In the Bilucuras household of 6, the average text messages sent in a day is 1,300. Meanwhile, in the Dicos household of 5, the average text messages sent is 1,020 with a population standard deviation of 450. Find the mean difference of text messages sent in a day given a 95% confidence interval. With that problem, we have this given. H sub 1, or for the household 1, we have n sub 1 is equal to 6, x bar sub 1 is equal to 1,300, and the population standard deviation is 300. For the second household, or h sub 2, we have n sub 2 is equal to 5, x bar sub 2 is equal to 1,020, and the population standard deviation is 450. And in finding the confidence interval with two means, we are given with this formula. Quantity x bar sub 1 minus x bar sub 2 plus minus z sub alpha over 2 multiplied by the square root of the first population standard deviation squared over n sub 1 plus the second population standard deviation squared over n sub 2. Therefore, we are 95% confident that the mean difference of text messages sent in a day of the Dicos and Bilocuras is contained in the interval from negative 1180.2 until 1740.2.